Honestly, I'm not that big fan of Bitcoins, but I pay special attention to the cashless society, blockchain technology.
Over the past few years, you've consistently heard the term blockchain technology, probably regarding cryptocurrencies like Bitcoin. In fact, you may be asking yourself, what is blockchain technology? It seems like blockchain is a platitude, but in a hypothetical sense, as there's no real meaning that the layman can understand easily. It's imperative to answer what is blockchain technology, including the technology that's used, how it works, and how it's becoming vital in the digital world. What's your take on Bitcoin and cryptocurrency? And is there anything you don't understand? Kindly let us know in the comment section below. If you've ever wondered what blockchain technology is, then you're in luck, because in this video, we'll be explaining precisely that. Without further ado, let's get to it. As blockchain continues to grow and become more user-friendly, the onus is on you to learn this evolving technology to prepare for the future. If you're new to blockchain, then this is the right platform to gain the solid foundational knowledge. Through this video, you'll learn how to answer the question, what is blockchain technology? You'll also learn how blockchain works, why it's important, and how you can use it to advance your career. A blockchain is a distributed database shared among the nodes of a computer network. As a database, a blockchain stores information electronically in digital format. Blockchains are best known for their crucial role in cryptocurrency systems such as Bitcoin for maintaining a secure and decentralized record of transactions. The innovation with a blockchain is that it guarantees the fidelity and security of a record of data and generates trust without the need for a trusted third party. In other words, blockchain is a shared, immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. An asset can be tangible, like a house, car, cash, land, or intangible, such as intellectual property, patents, copyrights, and branding. Virtually anything of value can be tracked and traded on a blockchain network, reducing risk and cutting costs for all involved. One key difference between a typical database and a blockchain is how the data is structured. A blockchain collects information together in groups known as blocks that hold sets of information. Blocks have certain storage capacities, and when filled are closed and linked to the previously filled block, forming a chain of data known as the blockchain. All new information that follows that freshly added block is compiled into a newly formed block that will then also be added to the chain once filled. A database usually structures its data into tables, whereas a blockchain, like the name implies, structures its data into chunks or blocks that are strung together. This data structure inherently makes an irreversible timeline of data when implemented decentralized. When a block is filled, it's set in stone and becomes a part of this timeline. Each block in the chain is given an exact timestamp when added to the chain. The goal of blockchain is to allow digital information to be recorded and distributed, but not edited. In this way, a blockchain is a foundation for immutable ledgers and records of transaction that cannot be altered, deleted, or destroyed. This is why blockchains are also known as distributed ledger technology, or DLT. First proposed as a research project in 1991, the blockchain concept predated its first widespread application in use, Bitcoin. In the years since, the use of blockchains has exploded via the creation of various cryptocurrencies, decentralized finance, DeFi applications, non-fungible tokens, NFTs, and smart contracts. A simple analogy for understanding blockchain technology is a Google Doc. When we create a document and share it with a group of people, it's distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to the document simultaneously. No one is locked out awaiting changes from another party, while all modifications to the doc are being recorded in real time, making changes completely transparent. Of course, blockchain is more complicated than Google Docs, but the analogy is apt because it illustrates three critical ideas of the technology. Blockchain is an up-and-coming and revolutionary technology because it helps reduce risk, stamps out fraud, and brings transparency in a scalable way for myriad uses. Business runs on information. The faster it's received and the more accurate it is, the better. Blockchain is ideal for delivering that information because it provides immediate, shared, and utterly transparent information stored on an immutable ledger that can be accessed only by permissioned network members. A blockchain network can track orders, payments, accounts, production, and much more. And because members share a single view of the truth, you can see all details of a transaction end to end, giving you greater confidence, as well as new efficiencies and opportunities. In recent years, you may have noticed many businesses worldwide integrating blockchain technology. But how exactly does blockchain technology work? Is this a significant change or a simple addition? The advancements of blockchain are still young and have the potential to be revolutionary in the future. So let's begin demystifying this technology. Blockchain is a combination of three leading technologies: cryptographic keys, a peer-to-peer network containing a shared ledger, and a means of computing to store the transactions and records of the network. Cryptography keys consist of two keys: private key and public key. These keys help in performing successful transactions between two parties. Each individual has these two keys, which they use to produce a secure digital identity reference. This secured identity is the most important aspect of blockchain technology. In the world of cryptocurrency, this identity is referred to as a digital signature and is used for authorizing and controlling transactions. The digital signature is merged with the peer-to-peer network. A large number of individuals who act as authorities use the digital signature to reach a consensus on transactions, among other issues. When they authorize a deal, it's certified by a mathematical verification, which results in a successful secured transaction between the two network-connected parties. So to sum it up, blockchain users employ cryptography keys to perform different types of digital interactions over the peer-to-peer network. There are 4 different types of blockchains. First are the private blockchains that operate on closed networks and tend to work well for private businesses and organizations. Companies can use private blockchains to customize their accessibility and authorization preferences, parameters to the network, and other important security options. Only one authority manages a private blockchain network. Then we have a public blockchain network. Bitcoin and other cryptocurrencies originated from public blockchains, which also played a role in popularizing distributed ledger technology, DLT. Public blockchains also help eliminate certain challenges and issues, such as security flaws and centralization. With DLT, data is distributed across a peer-to-peer network rather than being stored in a single location. A consensus algorithm is used for verifying information authenticity. Proof of stake, POS, and proof of work, POW, are 2 frequently used consensus methods. Thirdly, we have a permissioned blockchain network, also sometimes known as hybrid blockchains. Permissioned blockchain networks are private blockchains that allow special access for authorized individuals. Organizations typically set up these blockchains to get the best of both worlds, enabling better structure when assigning who can participate in the network and in what transactions. And finally, there are consortium blockchains. Similar to permissioned blockchains, consortium blockchains have both public and private components, except multiple organizations will manage a single consortium blockchain network. Although these types of blockchains can initially be more complex to set up, they can offer better security once they're running. Additionally, consortium blockchains are optimal for collaboration with multiple organizations. One of blockchain technology's cardinal features is the way it confirms and authorizes transactions. For example, if 2 individuals wish to perform a transaction with a private and public key, respectively, the first-person party would attach the transaction information to the public key of the second party. The comprehensive information is gathered together into a block. The block contains a digital signature, a timestamp, and other important relevant information. It should be noted that the block doesn't include the identities of the individuals involved in the transaction. This block is then transmitted across all of the network's nodes, and when the right individual uses his private key and it matches with the block, the transaction gets completed successfully. Currently, tens of thousands of projects are looking to implement blockchains in various ways to help society, other than just recording transactions. For example, as a way to vote securely in democratic elections. The nature of blockchain's immutability means that fraudulent voting would become far more difficult to occur. For example, a voting system could work such that each citizen of a country would be issued a single cryptocurrency, or token. Each candidate would then be given a specific wallet address, and the voters would send their token or crypto to the address of whichever candidate for whom they wish to vote. The transparent and traceable nature of blockchain would eliminate both the need for human vote counting and the ability of bad actors to tamper with physical ballots. Miners create new blocks on the chain through a process called mining. In a blockchain, every block has its own unique nonce and hash, but also references the hash of the previous block in the chain. So mining a block isn't easy, especially on large chains. Miners use special software to solve the incredibly complex math problem of finding a nonce that generates an accepted hash. Because the nonce is only 32 bits and the hash is 256, there are roughly 4 billion possible nonce hash combinations that must be mined before the right one is found. When that happens, miners are said to have found the golden nonce, and their block is added to the chain. Making a change to any block earlier in the chain requires remining, not just the block with the change, but all of the blocks that come after. This is why it's extremely difficult to manipulate blockchain technology. Think of it as safety in math, since finding golden nonces requires an enormous amount of time and computing power. When a block is successfully mined, the change is accepted by all the nodes on the network, and the miner is rewarded financially. One major advantage of blockchains is the level of security they can provide, and this also means that blockchains can protect and secure sensitive data from online transactions. For anyone looking for speedy and convenient transactions, blockchain technology also offers this. In fact, it only takes a few minutes, whereas other transaction methods can take several days to complete. There's also no third-party interference from financial institutions or government organizations, which many users look at as an advantage. On the other hand, blockchain and cryptography involve the use of public and private keys, and reportedly there have been problems with private keys. If users lose their private key, they face numerous challenges, making this one disadvantage of blockchains. Another disadvantage is the scalability restrictions, as the number of transactions per node is limited. Because of this, it can take several hours to finish multiple transactions and other tasks. It can also be challenging to change or add information after it's recorded, which is another significant disadvantage of blockchain. Blockchain technology and stocks can be lucrative investments, and there are several ways to take the next step towards making your first blockchain investment purchase. Bitcoin is typically the first thing that comes to mind when it comes to investing in blockchain technology, and it shouldn't be overlooked. Aside from Bitcoin, there's also the option of investing in cryptocurrency penny stocks, such as altcoin and Litecoin. There are also certain apps and services that are in pre-development phase that are using blockchain technology to raise funding. As an investor, you can buy coins with the expectation that prices will go up if the service or app becomes popular. Another way to invest in blockchain technology is to invest in startups built on blockchain technology. Finally, there's always the option to invest in pure blockchain technology. As we prepare to head into the third decade of blockchain, it's no longer a question of if legacy companies will catch on to the technology. It's a question of when. Today, we see a proliferation of NFTs and the tokenization of assets. The next decades will provide a crucial period of growth for blockchain. That's all on our video about blockchain technology. If you enjoyed it, be sure to subscribe to our channel for more of our fantastic content. Please give us a like, share the video, and don't forget to turn on the notification bell for timely updates of our latest uploads. We value your feedback. Feel free to share your thoughts with us in the comments section below.